Hi, and welcome to chapter 6 of this course. So, in this chapter, you will learn how to analyze circuits with multiple resistors in series and in parallel. So, you will be doing similar with what you did in chapter 4, that is all about capacitors in series and in parallel. Then, you will also learn the rules that you can apply in analyzing circuits with more than one loop. Okay, so you have seen an example of a circuit or a circuit diagram from the previous chapters, but then here you will see it more complex, or a circuit with more than one loops or more than one closed path. So you will also learn how to use ohmmeter, voltmeter, and ammeter. Or in general, we call them as the electrical measuring instruments. Then you will also learn how to analyze circuits with resistor and capacitor connections. And lastly, you will also learn how power is distributed in our homes. Okay, so since we'll be focusing on circuits, so of course we'll be dealing also with current. And current is the charges or our charges in motion. Okay, and then always remember that the current flow is from higher potential to lower potential, or in other words, it is from the positive terminal to the negative terminal. Now, it is also important to remember what are the circuit symbols, since those are essential in analyzing circuits. So if you do not know what the circuit symbol of a real EMF or an ideal EMF, then you cannot analyze a certain circuit, or shall we say other circuit symbols that you have learned in your previous chapter. So without further ado, so let's move on to our first lesson. Okay, so circuits has two types. So we have the direct current and the alternating current. So we will identify or define first those two currents, and then later we will identify what will our focus for this chapter. So the first is the direct current or the DC. Okay, so direct current is a current with a steady direction or unidirectional current. Okay, so the direction is not changing, and it can be produced by batteries or fuel cells. So the current that being produced on the toys or in the toys is a DC or a direct current, since we are using batteries. Okay, then we also have the alternating current or the AC. So it is a current with changing direction. So it is opposite with the DC or the direct current. Then it is produced by generators. Okay, so in our houses we are using the alternating current or the AC. But in this chapter, we'll be focusing on direct current circuit. So only the DC or the direct current will be our focus for this chapter, since alternating current will be discussed in the later chapters. So here's an example of a circuit as shown in the picture. So yeah, so we have different circuit elements. Okay, so for our first lesson, we have the resistor connection. So we will have 5 lessons for this chapter. So we have resistor connections. Then lesson 6.2 will be Kirchhoff or Kirchhoff's rules. Okay, so I doubt which is which, if it is Kirchhoff or Kirchhoff, since it is a German surname or German word. So CH is being pronounced differently with different preceding letters. Okay, so lesson 6.3 is electrical measuring instruments. Then the RC circuits or the resistor capacitor circuits. And lastly is the power distribution systems. But this chapter will be concluded with some examples or more examples for the topics that we will have for this chapter. So lesson 1, 6.1 is the resistor connection. So just like capacitor connections, we have two, the series and parallel connections. So the first one is the resistors in series. So this is how resistors look like if they are connected in series. So they are just connected, okay, they are just connected in one line, okay? So we have there R1, R2, and R3. So you will just do the same with how you identify capacitors in series and in parallel, okay? So your R1, R2, and R3 can be replaced by one resistor only, just like in capacitor, you can have it, your three or more resistors can be represented by one resistor with equivalent resistance. So we will solve for the equivalent resistance of the resistors that you have in the connection or your network. Okay, so for series connection, so we have here the equation. Your equivalent resistance is equal to the sum of the resistances of the resistors. And then we have the voltage. Okay, so from your source, the voltage will be divided to each of your resistors. While the current in each resistor is just the same or equal. So as the current flows, so as shown in the figure, as current flows from R1 to R2 to R3, it will not be decreased or it will not diminish or increase. Okay, so your current will just be equal for your resistors in your series connection. Okay, so in capacitors, we are concerned with the charge that is stored in the capacitors. Here we are concerned with the current in the circuit. Okay, so we have here some important points to remember in series connection. So the equivalent resistance of resistors in series results in larger resistance, meaning your Req must be greater than your R1 or your R2 or in any other resistance, any other resistances in your circuit. Okay, dapat permis RQ must be greater kaysa kay R1, R2, and all other resistances in your circuit if it is in series connection. Okay? And then, series connection is a voltage divider. So, same sa giingon ka ganina that your voltage from the source will be divided to each of your resistors, while the current is the same in all resistors. So remember these key points or these important points for series connection to evaluate your answer if you are answering some problems. Okay, if you have calculated an Req in series which is smaller than one of your resistors, then your answer will be surely wrong. Okay, so next we have the parallel connection. So in parallel connection, this is how it looks like. Okay, so each leg at the left of the resistors will be connected, and the legs of these resistors on the right side will also be connected. So same lang gihapon siya og forma sa capacitors in parallel. Now just like in series, we can represent these three resistors here into one resistor with equal resistance. Okay, so what we have equation R1, 1 over Req is equal to 1 over R1 plus 1 over R. Okay? But then your answer here, okay, your answer here must be divided to 1. Okay? So, kung unsa man imong ma-solve diri nga answer, okay, diri nga part, or sa kani, kung unsa imong makuha ang answer diri sa kaning equation, i-divide nimo siya sa 1. Okay, later ako siyang i-show sa pag-solve sa ato ang sa example. Now, your voltage is just equal for all of your resistors, while your current will now be divided to each of your resistors. So important points, the equivalent resistance of resistors in parallel results in smaller resistance, meaning your Req in parallel connection must be lesser than your R1, R2, R3, and so on. So if you are asked to solve for the equivalent resistance of resistors in parallel, then you have a calculated value that is that is greater than one of your resistances, then your answer will be wrong. Okay, since it is said that it must be smaller than the other resistances in your connection, in your parallel connection. And then we also have parallel connection is a current divider. So as shown in the figure, in the equation, your current is divided into your resistors, while the voltage is same in all resistors. So opposite lang siya sa resistors in series. Sa resistors in series, okay, your Req must be larger than each of the resistances of each resistor in the connection. Then, ano dito, ang i-divide dito is voltage and not the current. Then, ang equal dito sa series connection is the current, and ang sa parallel pod is ang voltage na pod ang equal for every resistor. Okay, so these important points are very useful in evaluating your final answer as well as in solving the problems related to resistor connections. So let's have here our first example. Okay, so we have our first example. Compute the equivalent resistance of the network shown and the current in each resistor. Okay, so the source of EMF has a negligible internal resistance. So as shown in the figure, so we have, okay, we have here your ideal source of EMF since it has no internal resistance. Remember that a small r is an internal resistance. Then your capital R's are the resistances of these resistors here, okay? So we need to solve for the Req. Okay, we need to solve for the Re. So the Req. So what will be our Req? And then the current in each resistor. So we have three currents. Since we have three resistors, so in each man daw, sa kada isa na resistor, so we will name it as I1, I2, and I3. So, since we name them as I1, I2, I3, then we need also to name the resistances given in the problem. So, since we already know, we analyzed the problem, we know what are to be solved, then now we need to write the given from the problem. So we have an EMF that is equal to 18 volts. So your internal resistance equal to 0. So we will name your 4 ohms as your R1. Your external resistance. So we have 4 ohms. Okay. And then your R2. Your R2 will be our 6 ohms. So, yung nakita kong ohms na symbol. And then, our R3 will be equal to 3 ohms. Okay. So, ato na lang silang panganlan. So that, in our solution, dili ta maglibo, kinsa nga itong dapat i-input. So, now we're done writing all the given. Then, next, we need to identify the connections of each resistor. So, just like in the capacitor connection, we need to identify. So we see here that your 6 ohms and your 3 ohms are in parallel. And these two resistors here are in series with 4 ohms. So same with capacitor connections or capacitor, capacitor connection or capacitor network, we cannot have 4 ohms series with 6 ohms. Okay, so dili pwede unahon si 4 ohms and si 6 ohms. We need to have first the parallel of 6 ohms and 3 ohms before nato siya i-series kay 4 ohms. Okay? So, now we need to solve for the REQ. So, we'll need to solve first the parallel part of the connection. Okay, so we will write here. So, your 6 ohms is your R2 or our R2. Our 3 ohms there is our R3. So we will write here as R2 and R3 parallel. Para reminded ta that kung unsa manggaling ang connection sa atong resistances. So for parallel connection, so remember we have, since it will not be our final answer, so ako sang i-name ang ihang answer. Ang equivalent resistance ni 6 ohms and ni 3 ohms, I will write it as R23, okay? Kaya ako manlan as REQ the final answer, okay? Ang final answer ako manlan o equivalent resistance. Okay, so we have, since kay kang R2 and R3 man ni, and kabalo kung dili pa siya mao ang final answer, so we have R23 equals 1 over R2 plus 1 over R3. Okay. So, sa ingon ako kaganina, no, whatever the answer will be with this equation, you need to divide it to 1. Okay? So, para easier, so instead of this one, so we will have your R23 equal to 1 over 1 R2 plus 1 over R3. Okay? So, we will be using this equation. Okay. So, para dili ta makalimot that we need to divide the answer, okay, the answer of this one to 1, okay? Para dili ta makalimot. So, but it's up to you if how you will solve it, okay? So, sa ako alam, so that I will not be forgotten, or para dili na ako makalimtan, nga kailangan pa siya i-divide sa 1, so ingon ani akong ginabuhat, okay? So, kung unsa man galing akong answer ani, mo na to ang final answer, okay? Kaya again, kani siya, after ani, i-divide sa ani mo siya sa 1, which is mo ni siya, okay? So, we have R23 is equal to 1 over 1. R2 is, pila si R2? 6 ohms plus 1 over 3 ohms. Okay. So, our final answer will be, or final answer for R23 will be 2 ohms. Okay. So, after we have parallel connection of those two resistors, then we can now have a series connection with the 4 ohms. So, now we will have your R1 and your R23 here, R23 are now in series. So, kana ko nung si 6 ohms o si 3 ohms, pwede na to siya bayloan sa resistor nga na ay 2 ohms na value. Kay same ra gihapon ng ihang product, okay? Ang ihang final, okay? So, for series, you will just, so since mo naman ito final answer, so I will name it as REQ. So, we have just R1 plus R2, 3. Okay. So, your R1 is 4 ohms. Then, R23 is 2 ohms. So, meaning our REQ will just be equal to 6. So, our 4 ohms, 6 ohms, and 3 ohms resistors in that network can be replaced by one resistor having this value of 6 ohms. Okay, so pwede rin natin siya bayluan kanang tulo ka buok sa usa lang ka buok resistor, which is equal to 6 ohms. Okay, so that is for the equivalent resistance. Then now we need to solve for for the current in each resistor. Okay, so the current in each resistor. So our I1 here is the current in R1. Okay. And then our I2 will be the current in R2 and our I3 will be the current in R3. So let's solve first for I1. So for I1, we will have it as, um, remember the, what do you call this one? The Ohm's law that we have V is equal to I R. Now from this equation, then we have your I, which is equal to V over R. Okay? So from this, for the I1, since it is in series, okay, okay. So your I there will be your I1, and your V will be your VEQ. So your VEQ is your source. Okay, okay, we'll have it as the, um, okay, your EMF over, ay, ato na lang isa-isahon. Okay. So again, your V there will be your VEQ or your EMF. Okay, let's have a VEQ over our EQ. Or your VEQ will be your EMF over your REQ. So your EMF is 18 volts. So we have 18 volts over 6 ohms. So our answer, I1, is just equal to 3. So for the current, the unit is amperes. So we have 3 amperes. Okay, so that is the answer for the current in your first resistor. Okay, so if we have done it for equivalent resistance, we combine all resistors to solve for the current. We will then ato na siya po na ibalik na ato siyang himay-himayon or ato siyang bungagon. Okay. So next, we will have the R2. I2. Okay. Now remember that your R1, okay. So I will redraw it, okay? So okay. Okay. So this is our R1. This is our R1 and this is our R2, 3. Okay. So this is the combination of our two resistors, R2 and R3. Okay. So since you already know that our I1 is equal to 3 amperes, then we need to solve for the uh, current in I2, in R2 and in 3. Okay. So again, remember that the current in a series connection is just equal. Okay? So meaning your I1 Okay, your I1 or the current in your R1 is just equal to your current in your R23. Okay, so I23, which is equal to 3 amperes. Okay, but here your R23, okay, your R23 or your R1 and your R1, your R2 and your R3 are in parallel. Okay, originally they are in parallel connection. Okay, R2 and this is our R3. Okay, and in parallel connection, your voltage is just equal. So meaning your V23 is just equal to your V2 and your V3. Again, in a parallel connection, the equivalent voltage of these two is just equal to the individual voltages of your R2 and the voltage of your R3, which is your V2 and your V3. Okay, now, but then the current is being divided in your R2 and your R3. So your 3 amperes is divided to your R2 and your R3. So we have here I1 is equal to your V2, no, your V1, sorry. Your I2 is equal to your V2 over your R2, and your I3 is equal to your V3 over your R3. So we already have the R2 and the R3. However, we do not have yet the V2 and the V3. So we need to solve first for your V2 and your V3, which is just equal to V23. So we cannot solve V2 using R2 and I2 since we do not have I2. Okay? But then we can solve V23 using the Ohm's law. So we have your V23, which is equal to your I23 since present man and current at R23 and your R2. So your current R23 is 3 amperes and your R23 is just equal to 2 ohms. Okay, in our previous calculation. So now we have that your V23 is just equal to your 6 volts. Okay, so we have 6 volts for the voltage. Okay, so that is our V23. And since your V23 daw is equal to your V2 and your V3, then we can now solve for your I2 and your I3. So therefore, your I2 is equal to 6 volts over R2, that is 6 ohms. So you have your I2 is just equal to 1 ampere. And then your I3, V3 is still equal to 6 volts. And your R3 is equal to 3 ohms. So then you have 2 ampere. Okay. So this will be your I2 and your I3. So checking our answer if this is logically correct. Okay, so let's have again the concept for parallel connection. Again, for parallel connection, your R2 and your R3, the current is being divided. Okay, so your IEQ must be the sum of your IEQ here is your I23. The combination of your R2 and your R3 is your R23. Now the current in that R23 is your I23. Meaning your I2 and your I3 must be equal to, if you add the I2 and your I3 must be equal to 3 amperes. So let us check. So I2, 1 ampere, I3 is 2 amperes. If you add those two currents, then you will have 3 amperes. Okay? So let's recall what we did in this part. Okay? So we have solved that your I1 is equal to 3 amperes. Okay? And then, since your I1 or your R1 and the combination of your R2 and your R3, which is R23, is in series. And remember that in series, the current is equal. So your I1 and your current in R23 are just equal, which is equal to 3 amperes. And in parallel connection, okay, your R2 and your R3, the VEQ, which is your total, okay, your total voltage in that connection is just equal to the individual voltages of those resistors. So to solve for I2 and I3, we will use the Ohm's law. So I2, of course, you will use the V2 and R2, and for R3 is the V3 and the R3. Okay, so we don't have yet the V2. So we cannot solve I2 since we also have an unknown V2 and an unknown V3. But then, as shown here, V2 trigono is equal to V2 and V3. And your V23 can be solved using still the Ohm's law. So we have V is equal to IR. But since we are to solve for the V23, then we need to have I23 and R23. So R23 is already solved as well as the I23. Okay, so we just multiply those two, then we have 6 volts. And then just plug it in the equation, then we will have the final answer. So that is for parallel and series connection of resistors. So thank you for listening in our lecture for this day or our lessons, the lesson 6.1.